All right, so chapter 3, problem number 23 is a projectile motion problem. It reads, a cannon elevated at 40 degrees is fired at a wall 300 meters away on level ground, as shown in figure Q 3.23. The initial speed of the cannonball is 89 meters per second. A, how long does it take for the ball to hit the wall? And B, at what height h does the ball hit the wall? So the first thing we'd want to do to start with, now that we have this information, the first thing we probably want to go with is let's find the components of this initial speed, make our life a little bit easier later on. So we can start by finding v sub I x, which will be 89 cosine of 40, and that ends up coming out to 68.2 meters per second, and v sub I y, which is 89 sine of 40, and that is 57.2 meters per second. All right, so that's the speed in the x direction and the y direction that the cannonball is going to have when it gets shot and leaves the cannon. That speed is going to change as it travels through the air, but that's what it is right in the beginning. We know from previous work that the horizontal component of the speed is going to stay at 68.2 because nothing is accelerating it, right? Nothing is changing its speed, whereas in the y direction, that 57.2 is right when it leaves, but it's going to slow down and eventually reach 0. And once it passes 0, then it's going to actually speed up in the negative direction or the downward direction, all because gravity is causing it to accelerate. All right, so part A, they would like to know how long does it take the cannonball to reach that wall. So looking at the fact that we have the speed in the x direction, we have the distance that the cannonball travels in the x direction, we should probably start with our second kinematic equation of x equals x sub O plus v sub I x times t plus 1/2 a t squared. If we take the origin to be where the cannonball is, then x sub O is 0. And like we just talked about, the cannonball is not accelerated in the horizontal direction, so this term here where the acceleration is going to be 0. So the distance in the horizontal direction that the cannonball traveled is 300 meters. The initial speed is this v sub I x, which is 89 cosine of 40, which we found to be 68.2. And then times t. Solving for t, we find that it is 4.4 seconds for the cannonball to reach the wall. Then part B, they want to know in part B, what height is this height h? Okay. Now the thing that should be evident, or you should realize, is that this height h occurs when the ball has traveled 300 meters, and it takes 4.4 seconds to make that 300 meters. So keep that in mind as you do problems like this. How does everything relate to each other? So that height h is a distance in the y direction. So I'm going to use our second equation again, but only the y version of it. So y equals y sub O plus v sub I y times t plus 1/2 g t squared. We know that the y, which is the position in the y direction, is going to be equal to h. Y sub O is 0. V sub iy we found to be 57.2. T is 4.4 plus 1/2 negative 10, 4.4 squared. And we do our algebra out, and we come out that it is 155 meters tall. Okay, so that was chapter 3, problem number 23.